So in 1808, John Dalton pulled together the observations that were known in the field, and he came up with his atomic theory. I'll point out that back then, he wasn't meaning atom in the way that we mean it today, where it had a nucleus and protons and a swarm of electrons around it. He was just saying it's an indivisible object and has the smallest nature of a particular element. That's the idea that he was trying to get across with that. Now here are the four postulates that he added in. He said that all matter is going to consist of atoms. They're going to be fundamental building blocks and you can't divide them. We know now that yes, you can divide them into protons, electrons, and neutrons, but at the time they didn't even know the structure, let alone the existence of those internal particles. Second one was that you can't convert atoms into other atoms. They had been hoping to and trying to transmute lead into gold, but he said that's just not going to be possible. We do know now that there are nuclear reactions that can convert one type of atom into another. But still, remember, this is over 2 centuries ago. And this is a pretty solid theory at the time, and it still matches up well with observations to this day. The third postulate was that all atoms of an element are identical. And they're all going to have identical properties, including mass. So if you pick up one atom of oxygen and 2 atoms of hydrogen, and you put them together into a molecule, that water molecule that you build is going to be identical in all respects to any other water molecule. That's his postulate. Now, we do know that there can be some deviations there. A good example of that is uranium-235 versus uranium-238. He wasn't really aware of isotopes at the time. We'll bring up isotopes later on when we revisit the atomic theory and add some more nuance, but still, again, 1808, that's a very solid understanding of how things are going on. His fourth postulate, compounds result from specific compositions of atoms. A sugar molecule will have the same makeup of carbon, oxygen, and hydrogen, especially when we get more specific and call it either glucose or sucrose or fructose or whatever. But those compounds are always going to have that specific combination of atoms. Now here's something that's kind of neat. If we take these 4, we can actually rebuild all these earlier models. We can identify the model of conservation of mass by looking at item 1 and 2, where we say that all of the matter is made up of atoms, and you can't change one atom into a different kind. That means the mass can't go anywhere. It has to stay there. If you start out with one set of atoms, and you can't change those atoms, and you're still going to have those before and after, you've got to conserve your mass. If we add in number 3, that's also going to tell us that products will have the same mass as reactants, because we're saying that all of the atoms have to be identical as well, and they're going to build into the new molecule. For the law of definite composition, we can build that from the third and fourth postulate. All atoms of an atom are identical, they're going to have the same properties, and compounds result from a specific combination of these, which means that every time you build it, you're going to have the same final outcome. Same masses, same behaviors, all of that. That's part of the law of definite composition, and also goes even further. The law of multiple proportions. You can build that from 1 and 3. We said all matter is made of atoms, and they're indivisible, for now. And we said that all atoms are identical for a single element. And so the law of multiple proportions can stem from that as well. So those 4 postulates were able to identify all the key properties of these 3 major rules so far.